All right, so I want to go through the syllabus just briefly for like the first 10 minutes. And what I would encourage you to do, I have to figure out how to turn this. Maybe I've turned this. So I'm in New Jersey at my mom's house, as I mentioned. And so I'm trying to figure out, and I've had a really lovely break, and I hope you all have too. And all right, so we're at Chem 105, which is organic chemistry, which was the email I sent to you. So that was actually the first thing that I sent an email on Saturday to the whole class. Ezra and several other people did answer it. And some people I said, well, you almost had it. There was a reason I picked those elements, and it is because of organic chemistry. But there was a second piece with the bonus, which is if all of you answer that email by Wednesday, everybody gets a bonus point. So right now, I think about 5 or 6 of you got a bonus point because you did answer it before class started. The other thing, there are bonus points that show up. So if you do miss a class, well, let's just walk through the syllabus. The class is going to meet on both Monday and Wednesday. When I scheduled, they very much frowned on me having it 2 days a week, but I am going to be here both Monday and Wednesday. It's how I've always done it. Typically, we met for 7 hours. So part of that, though, was lab time that you'll be doing on your own. I will always be here at 5 o'clock on both Monday and Wednesday. And then I will stay after. These first 2 weeks, again, I'm in 3 hours later than, earlier than you. And so my bedtime, actually, we've already passed it. So I probably won't be staying on that late for these first 2 weeks. But I know like Haley last term, that worked for her, that she would come before class and then she had somewhere she had to be on Wednesdays and then she would come back on after. And so to ask questions and if there were things, you guys will have the Zoom link and the YouTube. So I upload to YouTube because that's what I learned how to do and that's what I know how to do. I've never been trained how to do all the Blackboard and stuff. So I'm kind of a novice, and so my students have actually been who have taught me. But it is a slightly different YouTube link than last term because it's going to go to the Chem 105 playlist for those of you who were in my class last term. The Zoom link and the YouTube link are on the syllabus, and they're also on the Blackboard page. There is also now a link to the text on the Blackboard page. I don't know if anybody ever reads the text. It's a free book. And the handouts. So it was a question somebody asked me, not from our class, but I build the folders 1 week at a time as we're going along. Like I'm flying by the seat of my pants here, as all of us are. And so I will typically open next week's folder, hopefully by Thursday, definitely by Friday, which will have the stuff that you'll need for the next week. This week you do have an assignment due, but the other thing I wanted to point out on this side is 2 things. One is for those of you who are new to me, you are going to be scanning your assignments. So your first assignment is like a study set and a worksheet, and you all have the capability to print. Some of you have printers at home. You don't have to print. You don't have to draw these out because on these I'm looking for names, and we're going to go through this tonight for about an hour. But you're going to have to then be able to take a picture of what you did and submit it. And it does need to be, there is a key here because it really drove me crazy last term. It has to be in a PDF format and as one document. And so if you don't know how to scan, stay after today or come early Wednesday. And I just need to know what kind of phone you have and we can walk you through, or you can send me an email. I just need to know if you have an iPhone or an Android because it's 2 different ways for those. But it's pretty easy. Everybody's figured it out. The other thing I wanted to mention, and this was several of you last term were really awesome at this, is having some really fun colored pens. In organic chemistry that ends up making a difference to do your homework in different colors. and especially as we grade to go through it. Safety goggles, that's up to you if when you do the kitchen chemistry. And cations are positive. So an affirmation is a statement. Like somebody sent me this beautiful statement today and they said, I'm going to get an A in your class. So you should all write on somewhere a positive statement about how wonderful this class is going to be. And I've already said, I told a story once. I actually had a student who used to play, he didn't play at Mount Hood, but he was a baseball, football, basketball. He was like the team captain for everything. And his was always really interesting. His affirmation was never like, I'm going to get an A in the class. He always wrote we. He always, and so now I always tell that story. He's actually in the dental hygiene program. But he always would say, we're all going to do awesome. We're all going to ace this. And so he never saw it about himself, but it is about all of us. This is the tentative grading, blah, blah, blah. So there's study sets and worksheets. This first one is due. Let's just look at the other side. This is kind of our rough draft of the schedule that I'm planning to follow. And you are pretty much going to have a study set and a worksheet due every class after today. Unless it's a day, I call them celebrations. We say exams, that causes anxiety. If you see it as more, it's a chance for you to show me what you have learned and how much you've learned and to express that. And so I had some students who told me their teachers called them celebrations. And so I changed it to that. So study sets on Wednesday, your study set is due at 6 o'clock. So it has to be scanned and uploaded into Blackboard. And we then will go over the study set together. So I'm not looking that you got it perfect. I'm looking that you did your best. So let's say this is your study set. The study sets are 2 pages. That you tried something. Even if you got every question wrong, I'm not looking for blanks. I'm looking that you tried something, that you numbered your carbons and stuff. And this is why I have the office hour from 5 to 6. So if you are struggling, just come in. You won't be alone. Usually the office hour is about half of the class comes to go over some of the stuff beforehand to get an idea. So the study set, I'm just looking to see, did you try it? You lose only 1 point if you turn it in late. So everybody's going to have a day where it's like, I just didn't understand it, or I just didn't get to it, and it's not a big deal. The other thing is the study set is where your attendance is added in. So if you miss class, I take a point off your study set. You can earn that point back. Again, we've talked about it. So if you're somebody who has a conflict and you've talked to me and you're able to come to office hours, I've worked that out with you. And then, like I said, with the email, that there's random times that I do, more than random times. I often will have a bonus question in class during lecture, or I'll say a bonus question that if you email me, so if you miss class, when you go and listen to the YouTube, you can email the answer to me and you can get back that point. And so some of you, that was your saving grace. We had, this class was actually phenomenal at it. I think I gave out 15 bonus points. You can only get 1 bonus point a class. I had to start putting limits because otherwise it didn't work so well. So the worksheet is due at midnight. So on Wednesday, worksheet 1 is due by midnight. And in all honesty, if you get in at 2 in the morning, that's not a big deal to me. I don't do quizzes in this environment. They just don't work for me. And so the worksheet, I do not go over in class. It will often be easier to do it after we go over the study set. So you can try the worksheet and then realize once we go through the study set, that might answer a lot of your questions. And then you can always stay after class and say, hey, I want to go over some of the stuff on the worksheet. So I'm absolutely willing to go over stuff on the worksheet. This will all start making sense when we get into next week. A couple of things I wanted to point out. This is like my rough draft because I am used to having this class 2 days a week and not having as many conflicts as people have. So I kind of have to figure out where all the conflicts are and how to work it out. There are going to be 2 class presentations. And so the first one's the 5th week. There's about 20 people in the class, and so I'll be splitting us into 2 groups, and we will negotiate what the times are. So like Jeremy was in my class last term, and we did presentations, and they actually work really well. And so more details on those will come actually next week, because you're going to start doing stuff. The other thing I wanted to mention is labs. Labs are due by Saturday. The first lab is going to be a kitchen chemistry lab. There's going to be a video to go along with it, and that will be there by Wednesday. I'm still working on it since I'm having to redo all the labs. I think, yeah, and then the other thing, right, being honest, there's my words of wisdom, and study sets and worksheets that are late, they lose 1 point, and I'll take them up until the celebrations, like the first 5 would have to be in by the celebration, and you would just lose 1 point for it being late. Same with labs. And so once the celebration happens, we move on. We have to move on. I have to be able to move on. Is there any questions anybody has? The other thing is they're actually, so I did post the link to the free text. We're going to go ahead and start. And so remembering from last time is there are notes. You don't have to print the notes, but it makes it when we were live, I made everyone have printed notes for Chem 105, and that's because it's a lot of structures. So even if you don't have a printer, places like FedEx and stuff will allow you to go in and print. And so it can be helpful to have it printed. If you didn't print, remember I am recording, and so you can always go back and watch and fill in the blanks. So you guys actually have a huge advantage. I don't know if that's why my Chem 104 last term actually was the best 104 I've ever had. It was actually phenomenal. And so I decided to just keep going with the format that really allowed my students to do amazing. If you have a question, just kind of, you guys are muted. You should all be muted. And then you just push the space bar and you can start talking and I should hear you. So organic chemistry is the study of carbon. The basics, this was that it's carbon-based compounds. And so our life here on this planet is based on carbon. So the email, so you can all answer it now and should all be able to. So everybody has to answer it. I've never had this work, but maybe it could. Is the elements that we pretty much will see are carbon, hydrogen, oxygen, and nitrogen. The first 4 weeks of the term, we're actually only going to be working with carbon and hydrogen, and that's what the hydrocarbons are. But this first page that I will be spending our first 15 minutes on goes through some review of things hopefully you learned in a previous chemistry class. Depending how long ago that was, the first class can be a little bit of, well, there's a lot of review stuff, but that's why you have a study set and then a worksheet due. So the study set, again, we go over, and then the worksheet is for you to try, but I'm willing to go over it with you to make sure you've got it. So any idea why carbon would be our center?
Because they have the longest chains, they're able to bond more with other elements.
You're on the right track, Vincent. And by the way, welcome back. I didn't realize that was you when I was emailing you today. It is sure. Carbon, and there is one other piece to it. So carbon, that is half of it. The carbon makes these long bonds of carbon, 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 and that's what we're going to be seeing. All these carbons hooking up like that. And there is one other thing. There's one thing that I didn't mention, which is the periodic table. We really only use a small bit of the periodic table. There are also a few other elements that show up. Sulfur, phosphorus, the halogens will show up just a wee bit. The other piece to that is that carbon also makes 4 bonds. And that's actually what my next question was, which is how many bonds? And the fact that carbon makes 4 bonds ends up being part of the key. And then what Vincent said is we're going to just keep hooking them together, and they can make these long chains. They can make circles. And so I want to go through shapes and angles. And Jeremy, who actually is doing this in reverse order, he did Chem 106 first. And then there's a couple of you who are taking Chem 105 and 106 at the same time. So this gets really driven home, is this piece, the shape and the angles, determine if something's going to fit into the receptors, so the neurotransmitters. When they're trying to make a new drug, they're mimicking, trying to look at the angles and stuff. So carbon makes 4 bonds, and it can make 4 bonds in different ways. Like here I showed 4 single bonds. So anybody remember, Vincent, you don't get an answer again. You only get once a class, where once you get it right. So somebody else, the shape and the bond angle, we would call that. And I'm going to have you mute yourself too, Vincent.
Okay.
Does anybody else remember when you have 4 single bonds, what this is called in shape? And it's okay if you don't.
Is it tetrahedral?
It is. And what's the bond angle?
Isn't it? It's 109.
Yeah, and I have no idea who said that.
It's Allie.
Allie. How do you spell your name? A-L-L-I-E.
IE.
Okay. Yes, she is right. So 109 degrees tetrahedral. And this is actually what we're going to be working with the most this week, because we're going to start with alkanes, which are all single bonds. And so what is attached here to each of those can be, and yeah, I will figure this out. It keeps going in now, focus, but can be all sorts of different things. And we'll go through that for the next hour here. All right, another possibility is you could have a carbon with a double bond and 2 single bonds. And that gives us a different shape. So somebody other than Vincent and Allie, anybody remember what that shape would be?
Pyramid?
It is. No, it's not a pyramid. You know what, Philip? A pyramid is when you have 3 single bonds and a lone pair. Carbon is going to always make 4 bonds. So that is actually a comment we should put there. It's always 4 bonds. So you're not going to actually, with the carbon, have the pyramid or the bent, but we will see pyramids when we get the nitrogen and the oxygen, because nitrogen is going to have that lone pair. So nitrogen's actually going to make the pyramid shape. And oxygen's going to be really famous for making the bent shape. And I have to figure out why it's doing that. So any other ideas that you may remember?
Would it be the trigonal planar?
Yeah, so it's a planar triangle or trigonal planar. And actually, I think that was Emma, because you're, do you remember the bond angle?
120
Yes.
degrees.
Yeah, and that's what I tried to show drawing, that it's mimicking the 120, and we'll get into these, but it is going to have a double bond and 2 singles. So there is one other possibility, which you could have a carbon with a double bond on each side, or a carbon with a triple and a single. So anybody know what that one? It is. Was that Kaylee?
Yeah.
And you know the bond angle, Kaylee. What's a straight line?
180?
Yeah, it is 180. It's 180 degrees. So we're going to see these. So this is very different. The planar, triangle, and linear, these guys are flat. They're 2-dimensional. Tetrahedral, if you remember, this is where we get 3 dimensions. And so it starts pointing out at different angles and stuff like that. So when we start getting to the big molecules like proteins, this is going to make a difference, because suddenly you're going to have a twist or a kink and you're moving out into 3 dimensions rather than a flat 2-dimensional molecule. All right. So another piece is carbon always has 4 bonds. How many bonds does nitrogen have? Yeah, so Philip is back to that pyramid thing that nitrogen's going to make 3 bonds. And then it's going to have that lone pair on it that's a pyramid. So nitrogen, we're going to see, has 3 bonds. So if you had nitrogen could have 2 bonds. In fact, when we did this in Chem 104, we were doing it with general chemistry, and in Gen Chem, we often do anything that could happen. Organic chemistry, we don't actually do that. We do what actually does happen, and nitrogen makes 3 bonds, and it's going to be 3 single bonds. Outside the organic world, nitrogen can do like a double single or even a triple and a single. And so with that, what is going to happen with oxygen? And so how many bonds does oxygen make? And again, it's in the organic. Oh, and actually, let's back up for a second. Or does anybody know? Vincent, you don't get an answer again. He held up his fingers. Somebody, yeah, he's right. It is 2 bonds. The oxygen is going to make 2 bonds. And hydrogen, of course, those of you who've had me, I talk about hydrogen hell, that hydrogen only makes 1 bond. And this comes from the periodic table. This is our one brief moment that normally I'd be in class and I'd pointing at the periodic table so we could see that. But hydrogen's element 1, it has 1 electron, it makes 1 bond. Carbon it's their families, if you remember, and it's in a family where it needs 4 bonds to get to the octet, to be in that perfect place like the noble gases. Nitrogen has 5 valence electrons, and so it needs 3 more to get to an octet, and so it does that with the 3 bonds. And oxygen, we'll end up seeing, has 2 sets of lone pairs and then 2 single bonds. And it's sometimes we'll see that oxygen does a double bond like down here. So the game that we're going to play here is what's wrong with these structures. And again, it can be really helpful to print notes, and it can be you guys are in an environment where you can print them again, or even just look at them on the screen and make notes. And so we'll walk through A together, and then I'll give you a moment to look at the other ones. Is this very first carbon. So how things are written in organic chemistry. And again, this was something I was talking about before I started recording during my office hour. This first class is often overwhelming, but something really magical seems to happen, and I don't know what it is, but the students who are here in this first class, they get it somehow, even though you don't feel like you get it, and the rest of the term seems to go smooth sailing. And so you may want to go back and review this video, just so when you come Wednesday, because we keep building. Each class just builds on the previous class. And so you guys have an advantage since it will be uploaded onto YouTube. So the carbon, these hydrogens are written after what they're attached to. So I'm used to writing on the board really big behind me, which is why we put those boards in my room at home. And I don't have it in my old bedroom from when I was a little girl. But so this carbon is saying it has 3 hydrogens. And then this is a double bond. So 3 plus 2, that means this carbon has 5 bonds. And up here, this is really one of the central mantras that we use in organic chemistry. Carbon has 4 bonds, period. It cannot have 5. That would make it go beyond the octet, and that just does not happen. By the way, in case you're into like astronomy and stuff, and I know some people were talking about that they actually, I know you could not have been in Oregon or where I was to have seen the Jupiter-Mars conjunction, but they're actually looking for silicon-based life in other places because silicon also makes 4 bonds. And so anyway, it's a really cool topic. So this is wrong. So this would be our frowny face when it says look for the ones that are wrong. I'm going to go through every carbon on this just to help you because it's visualizing how things are written. So on this next carbon, it has a double bond on this side. So that's 2. It has a hydrogen. That's one more, that's 3. And then it's hooked to this carbon. So these carbons are hooked together. Yeah, we can write it out 1, 2, shoot. This is that color thing. So this is carbon 1, carbon 2, carbon 3, carbon 4. So if we're drawing this, this would be 1, 2, 3, 4. And so this is where the colored pens and numbering your carbons. Just today, that's a 1. So carbon 1, 2, 3, 4. And then my carbon 1 has 3 hydrogens. So those would be the 3 hydrogens around it. And then it showed a double bond, and that's why it just came out wrong. My next carbon, which is carbon 2, it has a hydrogen. And so like how we drew it back in Chem 104, we see this carbon has a double bond, a single on that side, and it has a hydrogen. When we get to carbon 3, it has 2 hydrogens, so one above and one below, and then it's a single bond on each side. So we often don't show the single bonds between carbons, but if there's a double or a triple bond, it is always shown. Like here, this is a double bond, so it would always show the 2 lines. And then my last carbon has 2 hydrogens, and then it has an O, and the O has an H. So again, be patient with yourself. This is why you have a study set due on Wednesday, so that you get the hang of how this works, and it just takes practice. And so this first carbon was our frowny face because it had too many. The oxygen's okay because it has 2 bonds. All right, so with that, let's move on to our next one. So this first carbon, we can go ahead and number. We have 1, 2, 3, 4, 5, 6. So getting colored pens, really helpful. All right, and numbering your carbons. I found the students who number the carbons end up doing really well with the class. So my first carbon has 3 hydrogens, and then it's attached to a carbon. So that's okay, that's 4. My next carbon, it's in the middle. So it's a monkey in the middle. It's got a carbon on each side. And so that's 2. And then it has 2 hydrogens. So that's 4. Same with number 3, same with number 4. So they're monkeys in the middle. They have 1 carbon on each side and then 2 hydrogens. So these are condensed structures where we're trying to show the hydrogens condensed down into that. We're going to see different ways that these are drawn. And so it's more you having an appreciation that you can look at them and it's like, oh, I see. Okay, it's not so bad that this first, like when you go to study for the first celebration in 3 weeks, you'll go back to this lecture and you'll be like, why did I find that so confusing? It's really not so bad. All right, so we're now on carbon 5, and some of this, sometimes when I save something to PDF, Bill Gates and Adobe, they don't communicate well and it shifts things over, and I didn't double check this, but that double bond was supposed to be on this carbon number 5. All right, so this carbon 5 has a carbon on each side. It has no hydrogens of its own, but it has a double bond. So it has a carbon, and a double bond, so it's okay. That's 4. And then my last carbon, it is not a monkey in the middle. This carbon here, the CH3, when you have ends, the ends aren't monkeys in the middle, so they're going to have 3 hydrogens on them. When you have a monkey in the middle here, the carbons in the middle, they can't have 3 hydrogens because they already have something on each side. They don't have room for anything else. So my carbons are okay. My issue, which you may have already figured out, is the oxygen. The oxygen has a double bond and a hydrogen. So the oxygen has 3 bonds, which is too many. So you can write 3 bonds or you can write too many. All right, so go down to B. So my problem on B right off is the first one. Carbon 1 has only 3 bonds, which is not enough, too few. So it has 2 hydrogens, and then it's just attached to a carbon again. My other carbons, they're in the middle, and they have 2 hydrogens. And again, as you do this, the first study set and the second study set, you become really proficient at this. If we look here, so we had carbon 1, 2, 3. 2 and 3 were good. Carbon 4, it only has one hydrogen, but that's okay. It has a carbon here, just one. It has a double bond, and so it only has one hydrogen. So that's okay. It has 4 bonds. I actually have a second mistake on this one, which is carbon 5. This one has 5 bonds. So it has a double, and a single, so you can see the 5 on that. Wow, this one had a lot of mistakes. And then our last one here, this carbon, again, oh, no, that one's okay. That one's okay. This one was 5 bonds, too many. I saw the CH2, but it had a double bond here. So the double bond, we'd only have 2 hydrogens. So that gives us 4. And the one up here, it has just a single bond and then 3 hydrogen. So it has 4. Right. So the hardest thing for me in this Zoom environment is it's hard for me to know when you have questions. So please do ask questions if you have them. Because you're not alone. Other people have the questions and you can always ask after. So on the last one, and I remember from last term they were into the chat box thing. I have my chat box turned off, so I don't actually see it during class. So if you have questions, you'll have to actually stay after and ask me. And yeah. And several of people were saying that they just forgot to print the notes, and that's okay. Just make notes as best you can, and you'll have to go back and review it when you watch it on YouTube. All right, my first carbon here, it's okay. It has 3 hydrogens. It's on the end. My second carbon's okay. My problem is this carbon here. So that carbon, it only has 3 bonds. It has a hydrogen and a carbon on the left and a carbon above it. And so it just doesn't have enough. The oxygen's okay. It has a single and then a hydrogen. So one of the things in this format is we often don't show the bond to the hydrogen. We just write the H in. And you're going to see that as we go through stuff. There should be one more question that I added to yours, and it has to do with the lab we're going to be doing this week, which is hydrophobic and hydrophilic. But before I go there, is there any questions with what we did? And again, this is just like a quick little intro. All right, so hydrophobic and hydrophilic. I know in my class I talked about it, in Chem 106 we talked about it, because it is actually a big, it's in chemistry we use the term polar and nonpolar. But when they talk about hydrophobic and hydrophilic, it's looking at it from a biological standpoint, because we as humans, this planet, all the living beings are really water is over 70% of our composition. And so we're considered water-based also. And so the word phobic means a fear of water. They're not actually, well, they are actually afraid of water. They will not mix with water. They're non-polar. So here's a question. And again, these questions that people answer, you get a bonus point. The most you can get is 2 in the week. So some of you have already got your bonus points today, so you don't get to answer again. But my question is, if anybody remembers, what would you be looking for? And it's something I did talk about in my Chem 104. In these pictures, it tells you that something's nonpolar. This is actually one of the biggest take-home messages we do this term, and it's going to get so ingrained in you. Does anybody know?
Is it a lone pair?
So that would be true in Chem 104, but we don't, that tells you, so that's a trick teachers use in Chem 104 that helps us get through the lecture, but I want a deeper answer than that of what that really means, what's going on. So it's kind of like, what does nonpolar mean, and which of these would be nonpolar and why?
Does it have to do with double bonds?
No, but again, that's a good answer. I'm going to take it one more step. The other word that you all have on your handout is hydrophilic. And so I'm actually right by Philadelphia. So phil means love. So hydro is water. And so these guys love water. So they love water. They mix with water. And so in chemistry, the term that we used was polar. And so the word polar, and this is what the first lab, and I'm making a video, hopefully tomorrow, it has to be tomorrow, that's going to go with the lab, and it talks about this, that word polar is like the North and South Pole, is there's actually a pull. So something is pulling. In nonpolar, there is no pull. And so the thing with the lone pairs, I don't know who said that, but so you're right, that lone pair happens because there is going to be a pooling. There's an asymmetry, and so there's a pool. And so what I was trying to go for is what is pooling, or rather in these, why there is no pooling. Any thoughts? So it has to do with water and why water is polar. You guys remember drawing water molecules? You've drawn them in so many classes that they are drawn never straight across, but they have a bend. In chemistry, we would put the lone pairs on, but it's not the lone pairs that are pooling, it's the oxygen. And so those of you had me, I talk about it, electronegativity. Do you remember that term? You don't really have to remember that for here, but oxygen's really greedy. It's what drives our life. Is oxygen is desperate for its own electrons. And so oxygen is pulling. It's pulling on these hydrogens. And so because it's pulling, those electrons in the bond are not being shared equally. The oxygen is pulling, and we get this pull. Whenever you see OHs, do green. Whenever you see oxygens, you're going to have a pull, and it's going to be attracted to this water molecule. So A, C, and D all are going to have a pulling. They're going to be hydrophilic, so you can put a heart with them. Alcohols have OHs. We're going to see that down here. So alcohols have OHs, so they're going to love water. These guys who all have oxygens, they're going to love water to a point. And that's one of the things we'll talk about as we go through the term. When you see oxygens, nitrogen. Again, I have a joke about NOF, so nitrogen, oxygen, fluorine, those guys pull. The halogens, they're going to pull. We're going to see they love water. So the one that's left out is what we spend the first 4 weeks on, which are the hydrocarbons, which is B. B is hydrophobic. If you see only carbons and hydrogens, carbon and hydrogen do not pull. They don't pull on each other. They just don't pull. There are carbons in the middle. It's just what it is. There's no pulling. And so it has no attraction to this pulling magnetic pull that's happening in the water molecules. And so the first 4 weeks, our first 5 study sets, if it asks you, is it hydrophobic? Everything's hydrophobic. It's going to be one of those rare times when the answer would be all of the above are hydrophobic or none of them. And then we're going to suddenly get into oxygens and then finally nitrogens, which is where it gets really cool. And we're going to have a pool. There is an exception to this, and that is that when you get to really big molecules like cholesterol, gosh, I can't remember off the top of my head, but it has like, let's just say 30 carbons. I know that's not the right answer. There's just too many, and it has 1 oxygen. That 1 oxygen might be pooling, but it really can't overcome the 30 carbons. So when you get too many carbons, it ends up hydrophobic, unless you have like an oxygen for every one of them, like happens in sugar. Now, something that's really cool that I learned, and I've never seen this before, I think it's happened in the past 3 months because I never saw this term before. And when I was Googling a picture for the slideshow, I came onto this new term. And so I don't know who made it up, but I love it. And so I get to teach it now. And I saw it a couple different ways. And so one was amphipathic. And so this prefix, amphi, anybody want to guess what this word means, apparently? I don't know who made it up, but I have a degree in biochemistry, and I've taught for 25 years, and I've used so many different books, and I've never seen this word. And even in the fall, when I was like getting stuff ready for things, I never ran into this word. And suddenly yesterday, I'm like, where'd this word come from? So it's that prefix amphi. Anybody?
Does it mean
Is it-
bigger?
No, somebody else was saying something. You had no, Vincent, yours was wrong. It's not bigger. But did somebody
Is it
else was
like-
saying
Like amphibian,
it is amphibian? And what is special about amphibians?
They're on land and water.
And so in terms of this, I don't know who's talking because it doesn't show me on Zoom. And was that Kaylee again?
Yeah.
Maybe. I don't know. Okay, I know from your laugh. So do you have any idea where that's going then with this, with hydrophilic and hydrophobic?
Water
Maybe like
loving.
one side?
It actually is both. It actually can be mixed for both hydrophilic and hydrophobic. So an example would be C. So C has this long carbon chain. So it's going to like things like this. It's going to mix with it because the carbon part of this is going to mix with this, but the OH part is going to mix with the water. Now, we had another word for that, and it was called emulsifiers. And I get into this as the term goes on, but nobody apparently could handle that word because it was too big. So they came up with this, which is amphiphilic, but then they realized, so it loves everything is basically what it's saying. So it loves all. So basically the hydrophobic isn't left by itself, but then they changed it. And I love this even more. And I cannot figure out why they came up with this. And so they kept it as amphi, and it's amphipathic. And I haven't had a chance to research where the pathic came from, but I'm like, well, an empath is somebody who fills you. And it's like when you're empathic, they say you can fill other people. You're very, when other people are very sad, you feel their sadness and stuff. And so these guys are amphipathic, which I thought was really funny that a molecule could be that. And I don't know who came up with this word, but I'll talk about it with the lab and you'll see it in there. The big thing here is when something is this, only carbons, the hydrocarbons, at the bottom, they're hydrophobic. When we start having oxygens and nitrogens, they can be hydrophilic until we get too big, which we'll worry about when we get there. This picture at the bottom of the page was just a quick representation of where we're going for the whole term. Again, for the first 4 weeks, we just stick with the hydrocarbons. We get them down, and then we start adding oxygen, and then we start adding nitrogen, then we start adding an oxygen and a nitrogen, or 2 oxygens, and voila, we see everything. So back to what we talked about at the top of the page. If you look here, this guy has 4 bonds. So something you're going to see me ask at times, since it's all single bonds, we would have the tetrahedral 109 degrees. We get here to the formaldehyde, we have a double and 2 singles. So this is back to that planar triangle. Yeah, we have a bunch of planar triangles. And then Philip, the comment you made, that would be here with the nitrogens. So these nitrogens, something they're not showing here is the lone pairs, but these nitrogens do have lone pairs. They are actually the tetrahedral pyramid shape. Anyway, places will be moving through the term, and it's a quick overview to where we're going on the next page. Which is, we are going to learn how to name organic compounds. And so that's the big piece. We're going to start with alkanes. And alkanes are also known, that the key is the ending A-N-E, is they're also called saturated. And that's because they're all single bonds. And so they are saturated with the maximum number of hydrogens. if you suddenly make a double bond, you have to kick out some hydrogens. And so saturated is when you're completely full. So when you eat too much, you're satiated. So that's the same idea. Or saturated, like right now here, even though we don't have the same amount of rain, we guys, I think, have had quite a bit of rain since I left. So the state of Oregon is pretty saturated. So there's a lot of words here, and I decided to leave the words there, so I wouldn't have to write them. What I found is it works better to just do examples. And as we do examples over this first week, you can go back and you just kind of learn it. But we are going to right now count from 1 to 10. And normally you would have to memorize 1 to 10, but you can make a little flashcard. We're going to use it so much this term, you're going to know it. It's like the metric prefixes last term, those of that, even though you always had a cheat sheet, but and it is learning how to count carbons. So if you remember on this side, I was counting my carbons. So this one had 1, 2, 3, 4 carbons. So it would be a bute, which is what 4 means, or this one has 6, which is hexa. So we're going to walk through counting the carbons, and we'll practice counting the carbons on the rest of these on this page. And then, all right, so when you have 1 carbon, the prefix is meth, and that is actually as in the drug meth, the street drug. So amphetamines are terrible drugs. And then they made it even worse by adding a methyl group, 1 carbon group on it. So it's a methyl amphetamine. And that actually made it even more addictive and cheap and all this other awful stuff. But that's where that term, but methanol is a 1 carbon alcohol. And we'll see that as we go through different ones. 2 carbons is F. So like ethanol. So when we have 2 carbons total, we'll have an F prefix. All right, and let's just go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I don't have to keep switching. All right, so when we get to 3, this one I know you've all heard of, but you might have not known it meant 3. It is prop. So propane is probably the most common one, most famous one there that a lot of people use, especially camping and hunting and stuff like that, for heating, or if your power goes off, a lot of people have a backup propane tank. It just means it's a 3 carbon. The ane ending, A-N-E, on propane means it's all single bonds. And there's one other thing I need to mention with the alkane being saturated, all single bonds. It is a hydrocarbon. So as I already mentioned, it's only carbons and hydrogens. So that's what we're going to be doing, is just single bonds, keeping it simple. So it means they're all going to be a tetrahedral shape. All right, 4 is bute, as in butane, which is lighter fluid, or butanol. So it comes, the prefix bute actually does come from butter. So the fatty acid most common in butter is butyric acid. And so that's why it's bute. And all right, so for 5, the rest of these actually go with the geometric names that you have heard before. So 5 is penta. So pent. 6 is hex for hexa. 7 is hept, H-E-P-T. So the month of September was originally the 7th month until Julius and then Augustus decided a month had to be after them. So there were only 10 months in the calendar. So September was named September because it was the 7th month, but it's actually hept. 8 is oct, so like an octopus. 9 is probably my favorite, which is known. So it's like no name. There's not many 9s out there. 9's not, which is interesting. The even numbers are more common actually in nature for certain reasons, and 5s. And then 10 is deck. It does go past that, and this is where if you actually speak Spanish or any other language, you would be better at than me, because instead of like we say 21, In every other language, they'll say like 1 in 20 or something like that. And so it's like dodeca, or sorry, unideca, dodeca, terdeca, and so on and so on. So we're just gonna, for right now, count 1 to 10. So when we do this, let's just do this example here. We're gonna just count straight across and number our carbons. So this is carbon 1, carbon 2. So we're just putting numbers on top of our carbons. And again, having colorful 3, 4, 5, 6. All right. So we have 6 carbons. You might be going, but no, there's a 7th one. There's one there. So the key is, this is the root, the number of carbons. It is the longest carbon chain, that should say continuous. So this is like a game of Pac-Man in which you cannot go backwards. You can only go one direction, and you need to gobble up the most carbons that you possibly can. So going straight across, if we try to go down and get this carbon and then come back up, we can't do that. You can't reverse. So we go across, there's 6, it's all single bonds. So the suffix is the family name. And so for right now, we're just doing ane. We're only doing alkanes. The families, again, were here. Organic chemistry, there are billions, probably trillions of molecules out there. And there's a very systematic way of naming. It's actually can be really tedious, but it's actually easier than all that naming stuff we had to learn in with the periodic table or even the English language, because it is systematic. So this is 6 carbons, all single bonds. We know it's single bonds because there's no double. There's no oxygen or nitrogen. So we're going to say hexane. So again, the ane is telling us it's saturated. So we have one more piece, which is the prefix. So we kind of write these words different. I always go with my longest chain and then my suffix, and then I go back and figure out the prefix. And you can guess the prefix is going to be this extra piece that was just dangling off there, right? And so it is what we call a side group. So it is a carbon, just one carbon. This is methyl.
Methyl.
So this YL ending means side group. So if it was a 2-carbon side group, it would be an ethyl. And we'll see that as we go through these practice, and they get more complicated. We'll look at the more complicated ones on Wednesday. Right now, I just want you to get the idea of doing it, and then you're going to try the homework, and then we'll see how you did with the homework on Wednesday. And again, the study set, sorry, I say homework sometimes, but study set. The study sets, again, you're going to submit it before class starts. I'm just looking to see that you tried it. It's okay if you totally bombed it, and then you're going to correct it. And then you're going to hopefully figure out what you did wrong and then be able to fix with the worksheet, which is always much shorter. But so we don't want to just say it's methyl. We have to say where the methyl is. And the methyl is attached to carbon number 3. So we say a 3-methyl. So the 3 is the carbon number it's attached to. I guess that's what I was trying to say here, side group with carbon number. And again, it's just going to take some practice here. So this is a 3-methyl hexane. So this is where the tediousness comes in, is whenever you write a number, the number is telling you the carbon number in the longest chain, you always put a dash between numbers and words. That's not a big deal to me, but that is the proper way to do it. Side groups have a YL ending. And then technically, this is all one long word. So I always make a joke that you guys would be amazing Scrabble players because you could write these really long words. All right, so let's try the next one together. Yeah. So we're going to start here. 1, 2, 3, 4, 5. So there's 5 carbons. So back up to our handy dandy list. 5 is penta. It's all single bonds, so we say pentane. And then we have this extra piece, and this is where, again, the colored pens are really helpful. Number your carbons. The students who number their carbons do so much better. You don't have to. I'm not going to force you to do it, but it does help. And then I like to circle my extra pieces. The really awesome pens are those erasable colored pens. I don't have those. I know there were some people in the class last term that they're really popular now, because that way if you make a mistake, you can erase. Otherwise, you probably want to use pencil. So yeah. All right. So this methyl is on number 3. It's at the third one. So we say 3-methyl pentane. So again, if you didn't print the notes, it is pretty impossible to try and draw these because you're trying to draw them. What I would do is just write down what they are and kind of just follow along, and you're going to see what I mean by you're going to want to print the notes so as we're going through them. All right. Let's go ahead and do the one next to it, because these are the zigzags. And I used to not teach the zigzags until the second week. And what happens, what I've learned is by the second week, you've all established your way and you don't want to change, because it's like, I get it doing it this way. And so I started 2 years ago, I put zigzags here on the first day. And lo and behold, everyone has, well, not everyone. There's always a special student. Most of the students end up preferring the zigzags. And actually, it's fascinating. One, Philip, I don't know if you've noticed, you're not the only male student, but last term he was the only male student. So there was like 21 females in the class. But there does seem to be a preference. I actually prefer the zigzags. So how the zigzags work is every corner is a carbon, including the end. So this is my carbon 1. This is actually the same picture as this. 2, 3, 4, 5. We don't show hydrogens when we do the zigzags. They're there because we know they have to be to fill in any blanks. So you don't show hydrogens. So they end up being these really crisp, clean pictures. So it's a pentane. So we're at pentane again. And then this extra piece here is just sticking off. That's my methyl at number 3. So we have the exact same thing, the 3-methyl. Now, again, what I find is about half of you end up loving the zigzags, and about half of you are like, they're nice, but I prefer these, and that's fine. When I draw them, you're going to see me drawing them both ways, and so you have to have an appreciation for both. When we get down here, you're going to be drawing them. I'll go through that when we get there. You have to be able to do it. I can do it either way, so you should be able to. Let's look at this guy over here. This is when we used to have this balls and sticks in class. Some of you had Chem 104 back when we met live. So this is, you can start at the top or bottom. We'll run into that more in the next class. That's carbon 2. So the black balls are the carbon. So 1, 2, 3, 4, 5, 6, 7, 8. So 8, there's nothing sticking off. The little white balls are just hydrogens. This guy over here is just octane. It's just showing us a zigzag 1, 2, 3. And so like Jeremy, you had Chem 106 with me and we did fatty acids, saturated fatty acids. You remember doing the zigzags. So, all right. So normally I would, because I would know everybody would have these printed. Let's go ahead and try the next 2. And hopefully sometimes, again, things don't line up right when it gets saved to a PDF. And I'm not the best at going back and checking to make sure that my lines didn't get moved. I do on the celebrations, but if it happens on a study set or a worksheet, just send me a message. All right, so this is 1, 2, 3, 4, 5, 6, 7. So I've been really nice to you all on this page. I made our longest chains go just straight across. When we get to the next page is, let's see, so there's 7 across. so heptane. And then I have these methyls. Now, I have two methyls, so we're going to be efficient here, and we're going to say dimethyl.
Two.
Yeah, so it's two methyls, so dimethyl. I have to give a number for each methyl. So one's at number 3 and one's at number 4. So 3 and 4. So 3, 4 dash dimethyl. So when you have more than one number, you put commas in between the number. Every side group has to get a number. If you have 3, like on the next one, we're going to have 4 methyls. So we're going to say tetramethyl. So we're going to have 4 numbers. So let's go ahead and try it. So 1, 2, that's 4, that's 5, 6, 7. So this one's a heptane also. And then we have to do all our methyls. And again, you don't have to circle them. Something I wanted to point out on this one, and I probably did this on purpose because this happens when you sometimes have them really close. Sometimes people will write methyls backwards on the left side. So they'll put H3 carbon. So there's 3 hydrogens on this carbon. Don't let that freak you out. It's the same as the CH3 as the methyl. All right, I have a tetramethyl. So tetra means there's 4 methyl groups. And now I have to give 4 different numbers. So the first one's at 2, and then 4, and then 5, and again at 5. So you have to tell me one's at 2, one's at 4, one's at 5, and another one's at 5. When you have 2 at the same one, we point one up and one down. When we do zigzags, if it's at a peak, it points up. If it's at a valley, it points down. These are things we'll see them as we go through it. Any questions? All right, next one. We're going to try and draw these. So I'm going to do them all 2 ways. You might want to do them actually 2 or 3 different ways until you find which style works for you. And some of you already know, oh, I like doing it this way, or I like doing it that way. And it doesn't matter to me. When I ask you to draw, I'm going to first do it by drawing the carbons. So when you draw them, you start at the end. I'm actually really looking to see that I have all single bonds. So next week we'll get into the double bonds. So I'm going to do 4 carbons. So 1, 2, 3, 4. And you can number them. It's really helpful to do numbering. And then I'm going to, at number 2, put a methyl. So my methyl is a CH3. It's just a 1 carbon group. Now I have to go back in. If you actually write the C, the carbon, you have to show the hydrogens. There's 2 different ways you can show the hydrogens. There's actually 3 different ways. So one is you can do it like we did up here. So I can say, okay, this carbon needs 3 hydrogens. This one, number 2, it's already got 1, 2, 3. It only needs 1 hydrogen. This guy needs 2 hydrogens. This one needs 3. So there's some students who like drawing them that way. Not many, but you might be one of them. I'm going to do the zigzags because I really like the zigzags. So you just go 1, 2, 3, 4. That's 4 carbons. Again, I'll number them. It's up to you if you want to number. So 1, 2, 3, 4. And then at number 2, I put my methyl, and my methyl is just a line. You do not write H's in at all. Never, ever. But if you show the carbon, you write your H's in. All right, we're going to do this one. Let's do the zigzag first. I'll do the zigzag down here. 1, 2, 3, 4, 5. All right. And I'm going to have 2 methyls. One's at number 2 and one's at number 3. So at number 2, it's up. At number 3, it's down. So that's what I meant. If you have a peak, point the side group up. If you have a valley, you point it down. So that is 2,3-dimethyl pentane. One of the methyls is at 2 and one is at 3. Again, this is why you have study sets every class, because you have to try it at home. And then as we go over it, you'll see the pieces you're not quite getting. All right, I want to draw it with the carbons. And I want to show you a different way. So we're going to start by showing 5 carbons, 1, 2, 3, 4, 5, because there's going to be many of you who are going to say, oh, I like this way better. And then at number 2, you put your methyl. And at number 3, you put your methyl. Now, when there are side groups next door to each other, like at 2 and 3, it's best to put one up and one down. It doesn't matter which one's up and which one's down, but that way they're not running into each other. And that shows me you clearly know that they're different. Now, the way you can show your hydrogen, rather than writing them in like this, which sometimes really confuses students when you're drawing them, is you can also just show them like this. You just show a line that this carbon needs to have 4 bonds. And we draw everything as a north, south, east, west, even though this is not what it really looks like. But it does show me that I have my 4 bonds. Now this carbon has 1, 2, 3, so it just needs 1 hydrogen. So we don't actually show the H, just show a line. This one needs 1 hydrogen. This one will need 2. This one will need 3. So I find a lot of students actually like that method. On the side groups, they like to show their CH3 or whatever it is because the methyls get easy. And so that's an acceptable way of showing the hydrogens. On this format, you never ever do that. You just ignore the hydrogens. All right, I'm gonna do one more here, which is hexane. So let's go ahead and I'm gonna take a deep breath. I'll let you guys try it first. Pick whichever method you like. The advantage is on the video, you can just stop me and try it. So in class, and again, if you get lost, just make a note to go back. I don't annotate my video at all. I don't have the time to do that. You can find it by scrolling. All right, and actually try it both ways. Try drawing it where you show your carbons and try doing the zigzags. You might want to do that even on the study set for the first week until you figure out which way you want, but you don't have to. I will be for the first probably 2 weeks. And then eventually I go to just one way or the other. All right, so 6 carbons is where you're gonna start. Now, my recommendation when you get to this many is that you wanna write your numbers. Even here, I should have written numbers to make sure I had the right number. Just writing them really small so they don't mess up your drawing. All right, so we have the 2-methyl. It can be helpful to underline as you get things done. So at number 2, I'm gonna have my methyl. And at number 3, I'm gonna have an ethyl. I'm gonna point it down. Anybody wanna guess what an ethyl is? Well, meth meant 1 carbon. F meant 2 carbons. YL means a side group, so it's a 2-carbon side group. So we're going to it's going to come out as a CH2CH3 side group. So that's an ethyl. That's my ethyl.
Okay.
And that one up there is my methyl. Now, if you turn this in, again, there's something I didn't explain. On the study set, you'll get 5 points as long as you made your best effort and you checked in with me somehow. Even if you're not able to be here for class, because some of you told me you had conflicts with, you would lose part credit. Worksheets are graded on having the answer right. And so again, you can always stay after and have me look over your worksheet. You would not get full credit because you didn't, if you show the carbon, the C, you have to show the hydrogen. And so I'm going to just show them as little lines. So this guy has just 3 hydrogens. At number 2, it's just going to have 1 hydrogen. Number 3 is going to have 1. Number 4 is going to have 1. Number 5, number 6 is going to have 3. Okay, I'm going to show it as where you can write it in like I did over here with them condensed, but not many students like doing that. That what this would look like, CH3, we'd have a CH with a CH3 pointing up. Then I'd have number 3 is another CH, and I have the ethyl group. And then I have a CH2, a CH2, and a CH3. Now, for most students, that can be a little rough to do. It requires more thinking, but it's perfectly fine. That would be our answer. And you can count your carbons. We have 1, 2, 3, 4, 5, 6. And what I found is a lot of students like the zigzags. So 1, 2, 3, 4, 5, 6. And then we add in, at number 2, we put our methyl, so just one stick. Now an ethyl is going to be a zig and a zag. So we zigzag this, an elbow. So there's my ethyl. All right, and again, we'll see more practice on the next page. And yeah, that's what I said, like on the worksheet, when you do your drawings, that you can use zigzags or you can show the carbons. And if you do show the C, you have to show the H either as the letter or the dash. So those were the 3 different ways I showed this one. All right, any questions? Okay. I'm going to keep going because I have to get through to a certain point, which is, I think, just this page. Yeah, I don't have to do that. I don't have to do that. All right, so we're in the home stretch. All right. So I'm going to pause. You guys can take a 5-minute break, or you take 5 minutes and see what you can do with some of these. And then I'll go through it. All right, so I'm going to pause. Recording. So I threw a couple curveballs at you on this, and there's something actually from the previous page I didn't mention. It has to do with the alphabet. Does it happen here? Oh, it's going to happen on one of these. I'll mention it when I get to it. All right. So numbering. On the last page, I numbered everything from left to right, like how we read. And it was lovely because I've made my notes so that I didn't throw any curveballs at you. But somebody usually asks me, do you have to always go from left to right? And the answer is, it depends. There is one right answer. And so when you guys are numbering, you want to think first. If I start here, I go 1, 2, I run into a side group. If I start over here, 1, 2, I also run into a side group. So it's which side you run into a side group first. And so they're both at number 2. It does matter. It's kind of like it's on a fulcrum, a balance point, and whichever side's heavier, it's going to get pulled towards that side. So we would number from this side because I run into the next side group at number 3. So I would have a 2, 3, 5 side group. If I numbered in the other direction, I would have side groups at 2, 4, and 5. So you always want the lowest numbers possible. Again, it just takes practice. So it's not that it's from left to right or right to left. It's really your perspective. So if you were looking at this from the back side of the paper, it would still be from left to right. All right, so we have 6. So this is hexane. And then our side groups are all methyls. So we'll number 2, 3, 5, trimethyl. I so miss writing on the chalkboard. Sorry, just had to say that. With organic chemistry, it just flows so beautifully. But I get to use colors, so. So 2, 3, 5, there's 3 methyls, 1 and 2, 1 and 3, 1 and 5. All right, the next numbering. Let's go ahead and number. Here we can see on the zigzags, for some students are very visual, you can see which side has the side groups and which side to start with. So we would just number 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 carbons straight across. 8 is oct for octane. And then at number 2, I have that thing sticking up, so that's a methyl. So it's just 2-methyl octane. Now, something about the zigzags that's really nice that I forgot to mention is the zigzags, besides being cleaner, they also are showing the bond angle. They're approximating what's really going on, which is that they're making this zigzag. What happens here is we flatten it into 2 dimensions. Remember, the tetrahedrals, these things are 3-dimensional. They're actually always zigging and zagging and moving around. So you could see something like this. Again, you don't try and write this down, but sometimes they'll even show where they'll curve it. And I didn't do that right. It happens down here, actually, we'll see. So it's not that it stops there, and this is a side group, you would keep counting around. So, all right, let's just ignore that attempt. All right, on B, I run into a side group at number 2 from either direction, but if I start over here, 1, 2, at 2 in this direction, I have a 2, 2. So I want to go where I get a 2, 2 rather than just a 2. All right, so that was beautiful numbering on my part. So 5, and I hope if you number like that, 1, 2, 3, 4, 6, and miss a point, that you will laugh at yourself and go, that was awesome, that I know how to count from 1 to 6. So we have a pentane, and then my methyls are at 2 and 2 and 4. So 2, 2, 4. So every methyl has to get its own number, commas between numbers, and then a dash, trimethyl. Now, something I also forgot to mention, I did say this is technically one long word, but I'm okay if you leave a space. Most students find they like to leave a space between the side groups and then the main chain. And you'll see me often start doing that when I give you ones to write out. I was trying to find an example, but all right, do the other B, the zigzags. And again, you've probably all already decided, I really like the zigzags, or I don't really like the zigzags, but I will tolerate it because I have to. All right, 1, 2, 3. Well, you don't have to do anything, but so that one is 6. So hexane. And then we have our blip set 2 and 3. So 2, 3 dimethyl. Hexane. All right, on the next 2, on D, I don't know what happened to C. We'll do C when we do the cyclos, I guess. Is our longest chain curves. So it's not the longest straight chain, it's the longest continuous chain. So I am going to start here, 1, 2, 3, 4, 5, and then this is number 6. So you will see that. Actually, there's several in the study set that just want you to figure out, like looking at them, because they curve in different ways of finding the longest chain. All right, so this is hexane. Again, this is the side group, and this is the side group. And again, the big piece about this first week is it changes how you look at molecules. And I end up making you all into super geeks that you'll be in a psychology class and you'll be sitting there looking at the molecules. The teacher will move on. And you'll be like, no, wait, that molecule. Or you'll go pick up a drug prescription for grandpa, and that little pullout that you always throw away, you'll suddenly go, oh, wait, there's like a molecule drawn on there, and you'll start looking at it. And but it has you look at them in a very different perspective and a much more holistic way, I guess. All right, this is a 2-carbon side group. So that's an ethyl. I'm just going to put an E there. And this is a 1-carbon or methyl. So when we write our side groups, it is the alphabet that determines the order that we write them in with the name. So we can sing ABCs, A, B, C, D, E. E comes before M. So we say 3-ethyl. We cannot combine the ethyl and the methyl because they are different. One's an ethyl and one's a methyl. And then we say -3-methyl. And again, I had you try it, whether you tried it or not. It's okay if you messed up. I mean, we were like live in class. It was much more fun because everybody would try it because I could see them. Dashes between words and numbers. So that's what would happen. Again, be somewhat forgiving of yourself because I am not an organic chemist. I have the bandana on because coal miners always wear a bandana. That's where the term redneck comes from, by the way, is the coal miners. So you can look it up in West Virginia. They were the first union. All right. So the next one, I know I start here because I run into that 2, 3, 4, 5. I'm going to stop there for a moment because if I keep going straight, I only get to 7. But if I do move down, I actually make it to 8. And that is actually the first rule of naming, is the longest continuous carbon chain. Again, it's a game. It's a Pac-Man game, but you can't reverse. You can't retrace steps. And you want to gobble up the most carbons. And so we can actually get to 8. So we're going to run into a new side group here. So we'll name our 8 octane. So this first 2 study sets, everything's going to end with ANE. All right, this is my methyl. So I can write my M there for methyl. I think you've all got your methyls down. Again, an ethyl is an elbow. So you just see one bend. This is not an ethyl. This is a peace sign. Peace sign is 3 carbons. I'm going to write it in a different color. 1, 2, 3. And 3 is propyl. But it's not a regular propyl. A regular propyl would be 3 in a row. If this had been my longest chain going across, this down here would have been a propyl. It's like a kink with a hand kinked more. This is what's known as an isopropyl. It's a peace sign or a little propeller and stuff. And we'll look at that again with the cyclos. That does start with the letter I, which comes before M, and it's attached to number 5. So we would say we have a 5 isopropyl. And it's okay if you have to write underneath and put a little arrow. I actually managed this right. 2-methyl propane, octane. And something else I forgot to mention, there is actually, again, usually this first class goes 3 hours. I usually do an hour introduction to looking at everything we're going to be doing this term, and it's on PowerPoint. And so I actually pre-recorded it. And since you guys weren't there, there was no interaction, so I did it in 30 minutes. And so that's actually the only thing that was there on our YouTube. So I would really highly recommend that you kind of watch it. It does have an extra credit in there, which for those of you who are with me, that's our healthy change extra credit. So please watch it this week and consider doing the extra credit. It's a 30-day challenge. And so you have to pick something to do for 30 days. It's kind of like your New Year's resolution. And you can talk to me about it on Wednesday if you have questions. All right. We are going to finish this page because I know it's on the worksheet and the study set. So cyclo means it's going to make a circle. And so what happens, we're going to do this with zigzags, is this is a cycloalkane. You could actually name her. That would be cool. Nobody ever draws the carbons in on these. They would not be a chemistry website. This is cyclohexane. So it's a hexagon. You can draw it like a spaceship, or you can draw a fallen over spaceship. I don't know. Now where to number depends on the side groups. So we're going to start adding side groups. But there is another one, and that is cyclopentane. So you can also do like octagon, like when I see a stop sign, I don't see a stop sign, I see a cyclooctane. So it would have 8 corners to it. So a pentane looks like a house, is traditionally how we draw it. So 5 around it. So cyclohexane and cyclopentane. They are almost always going to have side groups on them. So we're going to add pieces to them. Let's actually put it in the name and then we'll add it to there. So let's do another isopropyl. Let's draw. So isopropyl looks like that. So it's kind of like this antenna up. It can be anywhere. It could be the feet. So like her feet are probably an isopropyl. And then let's do that guy. So the elbow, the kink, which is what she's got going here with her arms. So if you remember, this is an ethyl down there on the side. And this up here is an isopropyl. So this is where the rules get really funky. On cyclos, your number 1 has to be at a side group. But it doesn't mean it's at the top because we're just stopping this for a moment in space. It's actually can be rotated any which way. So number 1 is going to be alphabetical. So ethyl comes before isopropyl. So ethyl gets to be number 1. Now, if there's only one side group, it is at number 1 and you don't say the number, it would just be ethyl cyclohexane. To get to the next one, you can go clockwise or counterclockwise. You're going to go the direction that gives you the lowest number possible. So in this one, we're going to go counterclockwise. So we're going to go 1, 2, 3. All right, so this is going to be 1 ethyl. So it's saying the ethyl's at number 1, and then dash 3 isopropyl. Again, as I mentioned, the names can get pretty long. And so you might have to like layer your name like I'm doing here. All right. We'll put a methyl on the cyclopentane. So if there's only one thing on there, it is at number 1. So we don't put a number. We just say methyl cyclopentane. And that's only for cyclos. It has to be at number 1, since number 1 has to be at a side group and we can rotate it any which way. We're going to do another one. Oh, I know what I wanted to do. All right, we'll do a cyclohexane again. And we'll do that. And I wanted to do this, which that is a Cl. So that's a halogen. So the halogens do show up in organic chemistry. They are man-made organic chemicals because halogens are extremely reactive and they will add the chlorine or the bromine on and will give it special powers, which make it highly reactive often, so they can make it into something else. Or it might give it certain things like it can be more absorbent of ultraviolet light. And so it can be used. I had a student who actually went on to graduate school and they were working with organic molecules and adding chlorines and stuff to make new photoreceptors for solar panels. All right, so this is not an isopropyl down here. These are methyls. So that's one methyl and that's another methyl. And so that's why I wanted to show that's an isopropyl. Those are each methyls. And this is a chloro. Now, I said alphabet goes first. So this would be chloro. We would think it's number 1, except, of course, because there has to be an exception. There's 2 things here. And so 2, it's a pair. Even if there were 2 different things, this gets to be number 1. So we're going to go 1, 2, 3. Again, this is a lot of information. This is why you have a study set, because you're going to have to practice this pretty much multiple times during the week. So that's what the study set is for. The study set is due at 6. The worksheet is due by midnight. I would recommend trying the worksheet and then waiting to submit it until after we go through the study set in case you have questions. When we do the study set, it should help. All right, so the methyls, in the name though, the chloro goes first because in the name, the alphabet always wins. So 3-chloro, 1,1-dimethyl, and then cyclohexane. So halogens, they just make them into an O. So fluoro, chloro, bromo, iodo. If it's a carbon side group, we put the YL on it. So there we go. Okay, we just have one more question. 2 questions with it. And well, actually, I have a question. On this page, which ones, so this is a bonus, so somebody who hasn't answered, it's your last chance. Which ones are hydrophilic? Is anybody there?
Anybody?
They all are.
I don't know who answered that, but it's the exact opposite answer.
None of them are,
None
because
of
they
them
don't have an
are.
oxygen.
They don't have
Exactly.
oxygen or nitrogen. They're all carbon. So these are all hydrophobic. So actually, that was a great question I asked. And a reminder, thankfully it's not an oral test because my brain mixes things up too, but don't assume the question is what you want it to be. Make sure you always look. And so I'd asked, I think, which were hydrophilic, and none of them are because they're just carbons and hydrogens. Now, this one is questionable, the chlorine, but there's probably too many carbons. But that's like a topic for a different day. All right, I want to go through these. Molecular formula means simplify. So the number of carbons, the number of hydrogens. So we're doing an alkane. So it's just going to be carbons and hydrogens. I'm leaving a space to write my numbers in there. So acyclic means it's going to be straight chained out. So what happens is every carbon, if you notice, if we go back like to the first page, every carbon had 2 hydrogens, actually the second page, right? So they all had, the monkeys in the middle had 2 hydrogens. So if we were looking actually here, the octane is the best example. So everyone had 2 hydrogens. So however many carbons you have, sorry, I lost my place. You double the hydrogens. So the rule is if we say we have X number of carbons, we have double the number of hydrogens, but plus 2 more. And that plus 2 is because the ones at the end have 3 hydrogens. So they have to fill in because they're not a monkey in the middle. So every carbon gets 2 hydrogens and then we have an extra 2. So this is the generic formula for alkanes, is however many carbons, double it plus 2. So 6 carbons. And we double plus 2 would be C6H14. And so that would be my formula. All right, so then the next one is a cyclic alkane. So the cyclos, the formula is different. For however many carbons you have, the hydrogens are always double. So I'll give one more chance. Why is it this time a different formula? What happens to the plus 2?
It's a circle, so there's no ends.
Yeah, was that Melanie?
That was Melanie.
Okay, I don't know who you are, Melanie, but your name for some reason, sometimes your names come up and sometimes they don't. Yeah, your name popped up to the top for some reason on my thing.
Oh, interesting.
So, right, she was absolutely right. Because we closed it off, we lost the plus 2, which were the ends. So if there are 14 hydrogens, then there must be 7 carbons. So that would have been our answer. All right. Any questions? For the good of. So for Wednesday, study says due, has to be uploaded by 6 o'clock. If you don't know how to make it a scan thing, either stay now and ask me or send me an email or just come early. And then your worksheet will be due by midnight. You can try it, but just realize as we go through the study set, that might help you with the worksheet. So in the past, they didn't get the worksheet until they were in class. So we had to go through the study set and then they would do the worksheet in class. All right, and I'm going to stop recording.